Hello, my name is Rich Howard, owner of Architectural Builder Supply. In this video is to bring you a closer look at the Schlage number L9010 03B in a 626 finish. In this video we'll go through an overview of the L series locks, what this lock is in particular. We'll take a look at the product catalog for options and variations, and we'll take a look at the template as well and talk about installation, etc., etc. So the bottom line is this is a passage set. That's simply the easiest way to summarize what this lock actually is. And let's start with a visual review of the item. The defining portion of this first, let's tackle, and that would be the 03B portion of the part number, and that is a reference to the trim. That means that we are dealing with a 03 lever with a B rose. The 03 is certainly not an uncommon lever, certainly not uncommon. But what is a little less common doesn't mean anything. It's just a little less common is the B rose. The B rose is the larger of the two standard roses. There's the A and then there's the B, and the B is a greater diameter. The 03 certainly makes for a very heavy lever trim, and that's because of what the 03 lever is and what it's made of. And we'll talk, let's just talk about that now. So the 03, as we pull up the documentation from the catalog, and there's a link below this video to a document called Product Catalog, and it's a large document because the L series locks are a comprehensive offering of a variety of variants of mortise locks: mechanical, wired electrified, wireless, electronic, and multi-point. And we're going to obviously focus down on just the mechanical portion of this comprehensive offering. So in the product catalog, the page that you'd want to scroll to, because what our point is to look at trim. Page 12 is important, as is 13. But first to page 14. Page 14 is going to be the standard, the common, the classic, or not all of them are classic and common. You know, they're the 03, the 06. These have been levers made for the 17. These have been levers made for a very long time. Other levers that are new by comparison would be the Asti, even though that lever's probably 30 years old. The Latitude is a newer lever. The levers that you're going to see on 12 and 13 are what they call their M collection, decorative levers. Very elegant variations on trim. And once upon a time, there weren't a lot of choices. The door hardware industry has gone from literally 100+ years ago. If you were to pull up a catalog of a lock manufacturer from the late 19th century, you would have an outrageous number of selections to choose from. Dozens. Well, at some point, 20, 30 years ago, the options really got tiny. And in the last decade or so, manufacturers have brought out these decorative levers, which is, something that I'm very grateful for, because once upon a time in a commercial setting, hey, it's like buying a Model T from Henry Ford. You can have any color you want as long as it's black. So of these M collection, or these decorative levers, the M52, we see that all the time. The M81, I've seen that as well. They're all legitimate options, obviously, but those are the two that just come to mind that I've sold. M51 I've sold recently. When you get back to the classic stuff, that 06, that is going to be the typical common lever that you see all the time. But break out of that. You don't have to use that lever. You can go with something better. Not better, but something different. When we scroll down to page 15, you'll see the Plymouth knob, the 41 knob, and the 42 knob, which is like an orbit knob. And when we get to page 16 is where we're going to break out and see the different roses, your A rose and your B rose, and you'll see your diameters there for those. And the reason that this is a, as I'd mentioned just earlier, why this is a substantial or heavy trim is because you not only have the B rose, but you've got an 03 lever, and that means, and across the line for Schlage locks, is that it is a solid cast brass lever. This is all solid brass. It's not tubular. Tubular would be a hollow tube. Tubular would be advantageous because the lever is literally lighter, which I would argue is advantageous in those situations where you have the possibility of a sagging lever trim. Schlage has basically solved that problem. I mean, levers, because they're heavy once upon a time, you know, were known to sag because literally of their weight. But the spring packs or the spring cages that they have can contend with returning the lever back to horizontal, because when the lever is not returned back to horizontal, when it droops a little bit, okay, that square preparation that you see turn inside of there is directly connected to its spindle. That spindle is connected to the hub of the lock cassette, or the lock body itself. When that lever is not vertical, what's happening when I rotate the lever, I'm retracting the latch. That means the latch is not fully projected into the strike when the door's in the closed position, which of course would be a tip-off to a fire door inspector when they see sagging levers. They're knowing in their head, I don't have proper projection of the strike of the latch bolt into the strike plate itself, which would be a violation of the integrity of the fire rating of the opening. So be mindful of selecting a lock that is going to, or a manufacturer of lock that will have that problem solved. You need that lever to snap back to horizontal every single time. Schlage does a great job with that. Really heavy trim. Really heavy trim. The entire, you know what, no reason to guess. I'm going to actually put this on a scale, which I've done, and this lever and rose weighs 1.29 pound. So it's basically a pound and 1 1/3 pound almost of almost solid brass. I would say that the handle itself is every bit of 1 pound. So it's substantial. Satin Chrome, which is what this lock is, and we're going to focus on the 03B 626 portion of this initially. 626 specifically means it's made of solid brass and has a satin chrome finish on it, a satin chrome plating. 626 is known to be the most durable artificial finish. If you want the absolute most durable finish, you're going to order this in 630, because that will mean it's not only solid stainless steel, it has not only will it have a brushed finish, but the base material is solid stainless. So very little to degrade over time. With enough use and time, you will see the satin chrome plating wear off. With hundreds of thousands of cycles, you will see gold undertones, revealing the fact that it is indeed made of solid brass. It's not a defect of the hardware. Everything wears with time. Everything fatigues with time. And the only time I've really seen the fatigue on the finish of a lock is after millions of cycles, well beyond any warranty period. So the fact of the matter is, understand the base materials of what you're working with. So if you're dealing with any of the finishes that Schlage can do these locks in, which of course is going to be a couple of dozen would be my guess. Let's pull up the price list and take a look and see how many finishes. Actually, we can just probably look in the catalog. So in terms of the finish options, and I am indeed looking in the product catalog. Okay, so you can do 31 levers, 2 knobs, and 9 finishes can be done in all their material. Being Schlage, they can most likely entertain requests for odd finishes. Black at one time was odd. It's no longer odd. It's black as the new oil rub bronze, it seems. So your brasses, your bronze, your chromes, your nickels, your satin, your polished will be covered. And they probably will do an aged bronze, that part number 643E. That finish itself was incredibly common in the 1970s. Etched bronzed is what it was called, and I bet I've thrown out cases of etched bronze locks back in the 90s. Anyway, let's continue on with moving through what this lock is and the contents of the box. Now, as we look through that catalog as well, we'll be able to talk about other options, but let's exhaust the balance of the contents in the box, or at least move towards going through them. So you're going to have your exterior trim, and you'll know it's your exterior trim because it's going to have these captive screws here with thread lock material put onto it. On the outside, there's no way to remove this. There's no way to pull that lever off. There's no hole for a spanner wrench. That is fixed, and that's how you know it's the outside. Okay. Then we know that we're going to have our inside trim. It's a little bit different construction in that the internal components are different, even though they literally are identical in design and size. The interior side is going to have this hole for a spanner wrench. It's going to have threads on the inside of that so that when you get it down over your rows, okay, you're going to tighten that down over the inner workings, and that will lock onto the lock itself that's ultimately connected through the lock body, and then your lever is going to work perfectly. So you've got your interior lever and rows. And let's get to the business end of the lock. That is your lock body. This is a 10 function or a passage function lock body. This is sometimes called a cassette. I don't know that a lot of people know it as a cassette. A lot of things in the hardware industry are termed, and those terms go back decades or more than 100 years. What it was called in 1890 is what it's called in, 2019. It's the same term. Cassette I don't see often used, but this is called a cassette. I think it's because it kind of looks like a cassette. If you're of that generation that used cassettes, I suppose that would make sense to you. Lock body is what people know it as. This is coming from the factory to work on either a right-hand door or a left-hand reverse. Easily reversible, and the instructions are literally on the box. So steps 1, 2, and 3. Pull and rotate the latch 180 degrees. You literally grab this and pull it out. And of course there's oil on it. And I am never very successful at pulling it out, even though you can. Okay, I did get it moved. And then you can kind of get it worked the rest of the way. Just take some hand strength, which obviously I don't have. And the name of this video is How Red Will He Turn? Okay. Okay, did get that kicked over and popped back in place. When I reverse that latch bolt, being intimately familiar with lock bodies, I would remove that plate and I would manually flip it over, because I find that the amount of oil I get on my hands just really makes it impossible for me to easily pull that out. So step 1 basically says rotate and pull that latch. Step 2, handing catch screw must be on inside of chassis. If necessary, remove catch screw from one side and install on other side. Catch screw. Okay, you can see where it's pointed to. Basically right here. There is no screw. Catch screw if necessary. The bottom line is this is a Passage. There is no catch screw because it is unlocked on both sides at all times. There is literally no reason to have a catch screw because it's a Passage. A catch screw would relate to a keyed function like a storeroom lock or an entrance lock, where one trim needs to be made and fixed rigid either all the time or whenever the function is set on the lock itself by either a turn of a thumb turn or maybe the rotation of a key or the stop works, the buttons that'll be in the side of a lock. Well, if you have a storeroom lock and it's a right-hand door, you need to have the, well, let's just say a left hand because this is a left-hand orientation. Let's say it's a left-hand lock. You need to have the catch screw on the right side, on the what does it say here? Must be on the inside of chassis. So the, what we would call the non-secured side, or what the electrified wireless alarm people would call the secured room side. In this storeroom application, the inside of the storeroom is the non-secured side from hardware. So what they're going to, by setting the catch screw on the proper side, is going to basically dictate what side of the lock body, okay, is going to be rigid, either all the time or whenever it's called for, like a classroom function. When you set that outside lock via the key control and pull the key out, now it's rigid. But the inside always needs to be unlocked, always needs to be active. So that catch screw needs to be on the proper side of the door so that you don't run into a problem of, oh gosh, I've locked the lock and now I can't get out. Okay, sort of scenario. Step 3 for RX only, install RX switch on inside as shown. There is no RX switch on this, even though there could be. There would never be a catch screw, but there could be an RX switch. An RX switch is called request to exit. And request to exit basically is a small micro switch with your wires coming off. I would imagine common, normally open, normally closed. That when you rotate the lever, that's change in state of the micro switch is reported back to something, a monitoring desk, maybe an audible alarm. Maybe, so to either turn on, you know, the light indicator at a console might show, you know, red for locked, and it might go to a green if that door is accessed. You might have an annunciator where you hit the request exit switch and then something starts beeping somewhere, you know, a horn. You might want someone to know, hey, that lever's just been rotated. You could have a request to exit switch connected to, in a scenario not on a mortise lock, you could have a Von Duprin exit device that's connected to a magnetic lock. You could put a request to exit or an RX switch in that panic device to tell the magnetic lock, excuse me, please, I'd like to leave. When you hit that, it will, you know, open the circuit to the mag lock, dropping power, dropping the lock off, allowing you a normal exit. So request to exit switches are kind of like relays in the sense that you can do a lot of things with request to exit switches that are really only limited by imagination. So, you know, an RX switch would be in there should it be necessary for you to have involved. Lock case, the outside structure of all of this is going to be capable of all of the function. It's really only the interior stuff that, you know, there's not a lot happening in a Passage set. I won't take the cover off, only because you can pull up the service manual and see the interior parts. Should you need to rebuild something, I will put a link to the service manual there so that you can pull up the L-Series, and then you'll be able to find literally all of those different parts that are on the inside of this lock. Now, along with the lock is called an armor front. This is a piece of metal, and in this case, it's steel with a satin chrome finish. Okay, that's how that's going to work. Now, the reference that I've seen to the term armor front has been in old catalogs, pre-World War I catalogs, where they had mortise locks, or maybe, 1920s and 30s catalogs, where they had mortise locks that had a super thick plate here that was incorporated as the solid single plate that you would mount the lock body to the edge of the door. So these screws are exposed. That long plate was generally about 7-inch long, maybe a little less. Not the typical 1.25" like that armor front, but like 1.16". A single thick plate, maybe 1/4 inch. And then I've seen in that same catalog variations of those mortise locks where it was a thinner piece with a second piece that they titled armor front. And I don't know if there is a difference in the composition of the armor front and the base material the lock is made of. I would imagine that it could be a reason why you would have an armor front. Let's say you might want something hardened on the outside, or something that would achieve an architectural finish, whereas a single piece here would not achieve that. If I had a single thick 1/4 inch piece here without an armor front, well, you're going to see all the screws. I'm holding it upside down. You're going to see these screws. If there was a cylinder, you would see the screws for holding the set screw of the cylinder in. Well, with an armor front, it kind of conceals all of that. Makes it nice and petite. Okay? So the only screws I see are the two little tiny 832 flat undercut head screws that are there. And then what happens is, as the lock body changes, the function changes, so does the preparation of holes in the armor front change as well. You could have a deadbolt, you can have your latch, you can have your deadlocking latch, you can have your stop works. So the armor front is definitely dependent on the function as well. This will be 8-inch overall height. This will be 1.25" overall width. Okay, it's probably about might be about 1/8 of an inch thick, maybe 0.13. Let's go 0.13. Oh, way off. Way off. 0.089. 0.089 thick. Not that that really matters, but nonetheless. Very important. It's going to have the F, UL, C. All of these little stampings here are visual indications of the caliber of the lock. What I'm trying to say is, if you're using hardware on a fire-rated door, it must be either listed or it must be listed and labeled. Listed means that it's been tested at the factory and it carries paperwork in the filing cabinet of the testing agency that says, yep, we took that hardware, we installed it onto a fire-rated application and it passed. Other hardware must be listed but labeled. It must bear visual evidence of the fact that there's a piece of paper in the filing cabinet at the factory that says, yep, we tested that lock on a fire-rated door and it passed. Hinges, ball bearing hinges made of steel base material, either steel or stainless steel, they're not going to have a listing on them. That's permissible by code. Spring hinges must have a listing, a label on them. All other hardware needs to bear visual evidence of the integrity of the lock in relationship to a fire-rated application. So be mindful that you need to have, if this is a fire-rated door, you must have visual evidence of this. The fire door inspector is not obligated to start pulling hardware off of doors to look for labels, even though there are times when you have to pull hardware off, meaning a door closer is not going to have it on the outside, even though sometimes they do. There'll be like a transparent decal on there. Sometimes the cover comes off and you look on the inside of the cover, or maybe on the body. Like a door viewer, that's got to come off the door so you can look at the label that would be on the barrel of the hardware. But that's, having visual evidence is on a fire-rated door is really what attention is being drawn to. And this Schlage lock is completely compliant with those ratings for fire-rated doors, steel doors up to 3 hours, wood doors up to 1.5 hours, etc., as required. Now let's continue on with a little tour of the interior componentry of this lock. Okay, now as we go through the balance of the hardware in the box, you're going to get a strike plate. This is a typical strike plate that's going to be used, of course, on your lock functions that will include a deadbolt. I don't like the fact that Schlage has packaged this lock with the catch-all strike. I don't think that it should be that way. Plus, I don't think that this is the best way to do a strike. When we look in the product catalog, you can get to page, at least the current page, 52, or just search for strike, and you'll get to the table where the different strikes are shown. You know, they do show the 10-072 L9010 series standard strike that has these two holes, completely non-handed, completely reversible. You know, the downside of that is you got more holes than you need. A Passage set does not require anything at all beyond a single hole. The downside of that being, of course, the fact that you now have a handed piece of equipment. Okay. So those having the hole at top and bottom, of course, permits you to run a non-handed environment. That's obviously one major reason that they do it. You will get a dust box, a plastic dust box. They used to be they used to be steel at one time. They're certainly plastic. I don't think Schlage offers a steel strike box. At all. But your installation will look like that. And that dust box is literally meant to help prevent the intrusion, the encroachment of wall material from coming from the wall construction out through the hole. It's a real thing. If you've got drywall, if you've got wood, you've got unfinished material on the inside, yeah, that's going to come in and out through your holes. You will see it on the edge of the lock, and the dust box is really important to have as a part of the proper installation. Be sure to install it. Don't throw them away. Don't not install them. An interesting fact about a dust box, an interesting fact about a door closer cover, okay? On a fire-rated door, is the integrity of the fire-rated door maintained if you skip installing the dust box? If you skip installing the dust box. And the answer is, no, it's not. And the reason it's not is because it is not specifically referred to in the installation instructions. So if you were to skip installing this, technically you're not going to be in violation of being afoul of the integrity of the fire-rated classification of the door, because the rule is that unless it's specifically stated in the installation instructions, let me back up. When it's unclear as to whether or not something is to be installed to maintain the integrity of the fire rating of the opening, the default is whatever the installation instructions say. In the case of that door closer, inspector went to a hospital and found many door closers that worked perfectly. The doors were completely in compliance. They closed, they latched, the margins around the door on all four sides were within tolerance. There was nothing installed on the door like a non-rated, non-listed piece of hardware. There was not excessive glass size or excessive signage applied to the door. But the inspector failed the doors because they didn't have their plastic covers. Now, my logic is, well, in the first 3 minutes of a fire test, that temperature is going to get to 1800 degrees, and then it's going to park there for the next 2 hours and 57 minutes. That plastic cover is gone. Does it help at all keep the doors in the secured position? I would say it does not. But the reason it fails is because the installation instructions state install the cover. So that's the backup. These installation instructions, very interestingly enough, do not call out the dust box. In fact, I don't call out the strike at all that I see. I don't see any reference to the strike. So I would not say that this is optional. I would say, however, install it in all instances. If you have a steel frame, it's very typical that your steel frame is going to have a mortar box, which can act as a dust box. On a masonry style frame, they call it a mortar box that are over the hinges and the strike preparation and any other hardware, power transfers, preparation over concealed closers, overhead stops, things of this nature. Any holes that have been drilled and tapped. As the welded frame is put in place, and the mason comes with the course of block, whatever masonry, as the courses are being laid, that trowel is scooping up pounds of mortar and getting it tossed inside of the throat of the frame as it works its way down. You don't have a mortar box on a strike prep, all that's going to extrude through that hole. A drywall frame won't have it, and that's where you for sure are going to want to use a dust box. Those mortar boxes will certainly work as a dust box. And just a tip, if you are installing welded frames into a masonry opening and you have any openings that are not covered, get yourself some white foam insulation from a home center and some duct tape. Put it behind there. If you've got some holes that are drilled and tapped, put it behind there. If you have any exposed area that you'll need to access, cover it up before the mason gets the mortar brought in, because that can make what would otherwise be a job of 30 seconds into 30 minutes. So be mindful of how to handle that best. Moving on through, so back to the strike. They do list in that table, forgive me, different strikes that are available. The bottom line is you've got the 10-072, your standard. They can also make a 10-072 with a 7/8 or a 1 inch or an 1.5 inch lip length or an 1 3/4 inch lip length. The standard lip length is 1 3/16. Now the overall strike is about 2 13/16. Well, the way strikes are measured is from the center line of the screw holes to the edge of the lip. That's where the 1 3/16 comes into play. Okay. About 3 3/8. This will certainly be 4 7/8. Okay. This is going to be 1 1/4 inch. Okay. So if you needed to affect the distance, change it from the center line of the screw holes to the edge of the lip, you can order different strike lip lengths. It does change the cost. 7/8, 1 inch, those could be incredibly handy, especially a 7/8 is when you have a mortise lock installed onto a classroom door. The door swings out and the school district applies latch guards to the face of the door and frame, but they're just flat latch guards. You don't have the ability to account for the lip in an installation like that because the lip is projecting. So what you'll see in the field is this ground down, cut down, whatever. Not the best idea because you don't get that nice radius, because as the latch bolt moves through its closing cycle, you really need to have the right dimension on here for this to get the idea and to say, oh, okay, you want me to let you in. Great. When you have something cut or modified, you're dealing with a blunt piece of steel. Sometimes they'll put a heavy bevel on it, but you want to order the right material. So be mindful of your lip length. Also, shorter lip lengths like 1 3/16, the standard. That's nice because it doesn't really hang off the face of the frame very much, and you don't ever want projecting hardware when it can be avoided. 1.5 inch or 1 3/4 inch, clearly longer than this. Why would you need that? Well, you could have a wall condition where when the door comes into the closed position and that latch bolt is hanging off, it's prematurely striking the wall or the jamb. If you've got extensions on the jamb, you could have a wood frame that's 4 13/16 or 4 9/16. Well, they build the walls at 5 3/4 or whatever, and they add jamb extensions on the pull side of the door. The problem is that strike is here. That my fingers are the jamb extension, and when the lock closes, it's already striking the frame. Longer lip length is what is intended to mitigate that sort of problem. You could also just simply have a deeper inset, like rather than when you stand on the pull side of the door, that inset is like a 1/16 of an inch, maybe 3/32. Well, imagine if that dimension was 3/4 inch, where the door was pushed in 3/4 inch. And you would get the same sort of effect if you were dealing with brick mold, you know, any sort of applied material to the exterior wall, brick mold, or maybe you've got shutters that come up tight. Or, again, you've got a wall condition where the drywall comes up all the way to the face of the frame and then back. So that rabbet of the frame really disappears into it completely. Or custom woodworking, where you've added a lock set to something and you've tried to disguise it with woodworking to paneling to match the walls or match the appliances. The bottom line is the lip length needs to be thought about. Schlage can do custom sizes, I'm quite sure of it, even though it's not specifically listed there. And if they can't get you the size you need, let us know. There are other manufacturers who can. But again, it's not listed in the catalog. I'm surprised it's not specifically listed, although it might be a special in the price list. Looking at the rest of those strikes, you are certainly going to see the armored front strike. Now that 10-091, that is an interesting strike because you can use it to great effect in different applications. Let's say you had a wood frame that was just beat up. You've got the typical 4 7/8 and you need to put a new mortise lock on there, but that wood frame is really damaged, either over time or it's been vandalized. Well, what you could do is just chisel out a much greater area and go with a larger strike. Remove all of the fatigued material and bring it back up to a nice, respectable looking condition with a larger strike. You could also have a pair of doors where you've got a mortise preparation in your active, but you've also got a mortise preparation in your inactive. Really not ideal. They make conversion plates that you could bolt to that 8-inch prep in the door, 8 by 1.25 inch, then attach this. Or you could go with the 10-091 strike, make some small modifications to it, and then install that strike right down to it. That might be an option for you as well. When you're looking at the 37-015 wood frame reinforcer, if you've got a wood frame, I would think you're definitely going to want to have that wood frame reinforcer. It's not included with this. It's a thicker piece of steel that might be, 150 thousandths. It has 2 holes in it that are offset, biased towards what would be the side towards the center of the frame, and then it's got the 2 holes to receive these screws. Well, those 2 offset screw holes will come with like 2 or 2.5 inch length screws, maybe even longer. I don't know the exact size. 37-015. They don't list it there. But you will drill, pre-drill holes through the frame into the stud and then sink those long screws into it. The purpose of them being offset is because in typical wood frame construction, let's say that we have a double rabbeted wood frame here. It could be single rabbet as well. You've got your drywall, and I'm just sketching this in really quick. Okay. The reason those screws are offset is because the point is to drill here and get them in to as much of the stud as possible. Okay, like that. Versus the standard holes, that line I just drew on top, that's not going to hit very much wood, so that's why they're off center. Okay, that's an exaggerated way to be able to understand why those holes are off center. The other strikes that are listed there are literally for their deadbolt, their L400 series. They're mortise locks, but they're just deadbolt functions. On that same page will be armor fronts. Now, as I had mentioned earlier, the armor front is based on the function of the lock. You will automatically get the appropriate armor front, but it makes it nice, this catalog, because you can look at it and say, okay, I need some parts. Oh, I know I can find that part in the catalog and get to the catalog. And the catalog's easier in certain instances than the price book because, well, you may not have access to the price book, but also there's a little picture shown there, and then you can get the idea. And Schlage has done, historically, a really exceptional job at making it very clear what it is that you're dealing with when it comes to these items. Now, continuing on with the tour of the parts in the box. Now let's go through the rest of the package. You're going to get a spanner wrench. This is just a piece of zinc dichromate steel, and the spanner wrench is a handy tool to hang on to. Unless you are sure you'll never need it again, keep this tool. First of all, you're going to use it to elegantly tighten and loosen this threaded portion. You can also use it in this fashion as well. You can also use it as a tool by which to depress the spring-loaded locking tabs to remove knobs off. The bottom line is this. People buy these spanner wrenches from us just to use as universal type lock maintenance tools, and I would encourage you to keep it somewhere. Because I don't know what they cost, but they're not free, and you have to buy these, so if you need one, you'll end up buying one. Then you have the two spring cages. Now the spring cages, those are easy. They basically install like this, okay? And what's going to happen is your spindle is going to go through the spring cage, and it's the spring cage that is what is going to keep the lever returning back to the position that it needs to be in. And there are installation instructions which we'll touch on in a moment. So in essence, what happens here is this spring, you've got two spindles. They're identical. You've got two springs. You'll need both of those. You've got your screws for the strike. You've got your screws for the lock body. You have your two 832 flat undercut head machine screws for the armor front to hold that onto the lock case. You have your two threaded posts, and then you have your two screws. The threaded posts and the screws are what allow you to install the interior trim through the door, through the lock, through the spring cage, through the lock case, through the door, into the exterior. So what really happens is the threaded posts go on, your spring cages go on, then bear with me one second. I didn't have pulled up in front of me the one part that I was looking for, and it was stuck in the package. And this is the gizmo here. So this is your mounting plate. This goes all through the door. Your spindle is sticking out of here. It's going to look like that. That all goes in there, and you want that spring there. Okay? Okay? You've got both of your mounting posts installed down onto the door. This all goes through from the outside to the inside. Then this post comes and sits down right onto the face of the door. Through here, you will take your two screws and put those into the threaded holes in the posts. Then your rose goes down. The rosette goes down. Then onto that threaded post, that's where this comes into play, and your spanner wrench. And you thread that right on, you're as right as rain. That's exactly how this works. Schlage locks are great. Always have been in terms of installation. Not a lot of deviation has occurred that I'm really familiar with in the mortise locks. They're cylindrical locks. They change parts every once in a while, and you say to yourself, what's going on here? I don't remember this. So what do? Well, the thing you should have done at the very beginning is check the installation instructions. And just to show you how the spring cage works, I'm just going to insert the spindle. Okay, so right now the spindle is engaged through the spring cage into the square receiver in the stem of the lever, and I can't, well, you know what, I can make that work. Just for sake of demonstrating, I've got that all engaged with the spring cage. It's not retracting because... And that pops just as a demonstration. That comes right back up. Nice spring cage capability. I wouldn't be able to do it otherwise just by my hand strength as we demonstrated earlier. So that spindle goes in there is the bottom line, but through it will go this spring cage. These spring cages are bought as standalone parts often, and it's not because they fatigue or fail prematurely. They don't. But you put 5 million cycles onto a Schlage lever lock, yeah, springs are going to start to fatigue, finish is going to start to wear, things of that nature. So be mindful of that. Now, let's just review the installation instructions and make sure that my very quick review did not put us in a position of forgetting anything quite important. There is a link below this video to the installation instructions, which we can look at, and some other items as well. So page 1 of the installation instructions really call out all of the different part numbers, and it's important to know part E, spring cage. Okay, part G that I couldn't mention, or that I didn't know the name of earlier properly, inside mounting plate. Well, I think I called it that. Okay, your spindles, your springs, and that's how that's supposed to look. You want that on there. That spring does the job of making sure that your spindle is always engaged in the retracting hub of the lock, because the inside of that spring is touching the inside of your trim. So that spring keeps the spindle inside of here, buried deep inside of here. So make sure you install it with those, because you might have a problem where that leaves the lock case, and that would be a bad situation when you wouldn't be able to exit or enter. Looking at the rest of the parts that are there, some of those items don't apply at all. Your K parts, your F, your P parts, N parts, your D, mounting posts, yeah, I got that right as well. That J part doesn't apply. And you quickly see all the parts as they float around. If we divided off of that everything we didn't need, the drawing would be much less complex. Now, we've got, after the prep is done, and we'll talk about machining it when we look at the template shortly, that lock case is going to go in. You're going to put your 2 screws inside of there, but before you do so, what I like to do, get the screws in, but leave it backed off a good 2 turns, let's say. And I like to dry fit the lock to make sure all my function holes are exactly where they need to be. If the door was prepped by you, great. You followed the template and it all fits down nice and tight and works properly. You want to be really sure that the holes are in the right locations, and if not, make any adjustments necessary. If you didn't drill the holes, by all means, do everything I just said. Double check that everything is where it needs to be. And what I like to do is do a reality check on the lock. What lock function do I have, which means what parts will be on both sides of the door, and I look at the door and say, okay, all those holes look right, or wait a minute, why is that hole there? Okay, you drill a cylinder hole on the wrong side of the door scenario. You don't want to have that. And that gets done because, you know, the factory will order left-hand doors, or someone will order left-hand doors, but they're really right-hand reverse. Yeah, if it's a storeroom function, you've got the cylinder on the wrong side of the door. So you dry fit the lock body, make sure everything visually looks like it's right on spot. So when you get that in the door, make sure that your cylinder is going to thread in without any trouble. You got to have a nice margin around there. Not a lot of room left over, and if it's drilled in the right place, then you don't have a problem. They do then get into, in step 2, showing how those springs and the spindles go together. You're going to use those only when you start to add the trim, and then step 3 shows you how to put those spring cages on and the mounting posts. So that all quickly comes together, which we did a bit crudely, but effectively demonstrate the assembly of the trim, and that gets us through steps 3, 4, and 5 doesn't apply to us in a mortise lock. Step 6 is important because that'll show us the inside trim function that has to happen as well. And it's okay that that plate is going to sit on top of your spring cage. That is the way it's designed, because your rosette, that I have been resisting taking out of the packaging, is going to fit like that. It's all going to be completely flush within the rows, the A rows, the B rows, those decorative roses that are there as well. Step 7 is the conclusion of the trim. showing the spanner wrench. Step 8 doesn't apply. We don't have any cylinders or thumb turns. Door handing. They talk about door handing, which we've demonstrated already. Getting us down to okay, so the installation instructions after we get to page 5 are now with escutcheon trim. This is sectional trim because the trim is in sections. Escutcheon trim would be rectangular plates, generally rectangular. They can be oval, but it's a single unified plate that is incorporated into the way that the hardware is mounted on the door. It's incorporated into the trim that's applied to the door. So you can have escutcheon trim or sectional trim. The B in the part number specifically means sectional trim. And the rest of the installation instructions are literally the escutcheon style. You can go back to the product catalog to look at the different escutcheons. The N escutcheon is one that comes to mind. Now let's take a look at that template. Okay, now at this point we've exhausted all of the parts in the box. If this was a different function, there would be more parts. I don't think there'd ever be less parts than a Passage. So now let's take a look at the template. The template, and we're going to circle back around as well to the service manual and back to the product catalog. So the template is simply far more intimidating than it's worth. Don't get excited about it. It ain't worth it. So the bottom line is immediately much of the template, I think there's 3 languages here. So imagine 1/3 of one. If you were working only in one language, you would see 1/3 of all of the printed documentation here. The bottom line is this. On the first page, they're showing a right-handed door. On the second page, they're showing a left-handed door. Okay? You need to be mindful of what you are drilling and where. This is where reality check comes in. Because if you say, well, okay, I've got a right-hand door, but it's really a left-hand reverse, you've got to say to yourself, okay, how do I interpret this template to give me the cylinder hole for a keyed function on the pull side of the opening rather than the push side? They do kind of make it easy in the sense that they say inside preparation. Okay. And then on the right side of the document, they say outside preparation. So I think they're dumbing the language down a little bit to help us understand how this material works. So page 2 is the same as page 1, except page 2 is a left-hand orientation, and page 2 is a right-hand orientation. And literally, page 1 has inside, outside. Now, if it was page 2, it would be inside, outside. Okay, so they literally just flip these two because this hand of the door has changed. So we're just going to look at page 1 for a right-hand door. On the left side, if you divide that page in half and look only at the left side, they're showing you what the inside of a right-hand door ought to look like. And conversely, they're showing you on the right side of that page what the outside of that door would look like. So we have a left-hand lock here because I flipped that latch bolt around. Okay, so let's do this. Let's just look at page 2 since this has the latch bolt in the proper orientation. So if this was a left-hand door and we're going to look at the outside of the preparation, okay. As I look at the template, it will show me the top screw away from the lock edge and the bottom screw towards the door edge. Okay, so this is a left hand. Okay, so it literally will mimic what you see on your paperwork. The top screw is towards the center of the door. The bottom screw is towards the lock edge. You'll notice that when you look at the right side of the page, those holes are flipped over. Well, sure it is, because, you know, they do get flipped over as you drill through the door. If you were to take that template and fold it in half, where you drilled one hole would indeed exit through the other hole. What I'm trying to say is the holes marked D for the mounting posts, those are not along a vertical center line, as are the other holes, and they're asymmetrically placed. But when you study it and stare at it, you realize, oh, okay, yes, it could only be that way. Some people drill the holes in the opposite corners thinking, oh, that must be how it is. It's not. Take that paper and just bend it over. Then the top hole towards the outside, or the center of the door on the outside of the prep, is indeed lined up with the top hole pointed towards the center of the door on the inside prep. That drill bit will exit through the same way. So that's the orientation of the through bolt holes. Okay, they appeared to be drilled in different places. They're not. It's pretty simple and straightforward when you study it. And that's what I do with every new template. And that's what I did for many, many years. Well, for a long time when certain pieces of hardware were new to me, I sat there and studied the template. There was one time I did olive knuckle hinges for the first time, and I kid you not, I studied that template for almost an hour before I did anything, because I don't recall exactly what was giving me trouble. It was something to do with the center line of the hinge on the door and its counterpart center line per the template on the frame. They were not the same, and I was really having trouble understanding that. Well, I studied it, and it came out flawlessly. Just jumping into it, you might have to pull the reins back a little bit if you move too quick. So the bottom line is this: the way to navigate this template, and not only Schlage, other people do it this way as well. They're showing you the different functions for the outside of the door and telling you the holes that you'll need to think about or to just make happen on both the outside and the inside of the door. So we have a passage set, and that's I'm going to go with only 3 holes: this hole, and this hole. That's all. And indeed, they list a hole marked A, a hole marked D, and a hole marked E. Well, A is for the escutcheon, so you're going to ignore that. We're not doing an N or an L. We're doing an A or a B. We're doing a sectional trim. So now you're only dealing with hole D and E. That's all. That's all there is to it. Those holes will literally go through the door, and how you know they go through the door is when you look at the inside preparation. You will see for the L9010 that the D hole and the E hole are required. So you know those go through. All you do is call up the function that you need, and those are the holes you're going to drill. What you could literally do is take your template and X off everything you don't need and just focus on those holes that you do need, and you're really in good shape. So now that you've identified the holes that you have to drill, it comes down to understanding, where am I going to place these holes vertically on the door? So there is a 3/8 of an inch relocation of the center line. This gets us into the woods a little bit, but it has to be understood. A 3/8 of an inch relocation of the center line from the strike to the lock prep. When you look to the right-hand side, you're going to see 3/8 of an inch. Wherever the center line of that strike is, the center line of your lock needs to be 3/8 lower than that center line of that dimension. Okay? It's true. It's a truism. It's for every mortise lock, almost every mortise lock, not all of them. I think some card access locks play with that dimension a little bit, 7/16 perhaps. But in a Schlage L9010 series, I'm not familiar with any that aren't 3/8. The reason that relocated center line has to come into play is because if you did not relocate the center line from the center line of the strike, let's just say it's right here in the middle, if they were both centered, and I'm just holding it up to the camera, what would happen is the deadbolt up here would not fit into the strike. So they literally take the lock and they drop it 3/8 of an inch. Now, where that deadbolt would exist will fall into it. And that's exactly why they relocate that lock body, because they can't fit it all into the footprint of the standard 4 7/8 strike. That's it. That's the bottom line. You have to be mindful of how you measure this stuff, and what I mean to say is this. What I mean to say is this. Don't take the same dimension necessarily and just add 3/8. So if you were to measure the top of the door, or if you were to measure the inside of the header to the center of your strike and come up with 43 11/16, and if you were to take 43 11/16 and add 3/8, well, actually that would work. You would drop that onto your door and you'd come up with 43 15/16. So that would work perfectly. The point I'm trying to make is with cylindrical locks, if you took 43 11/16 and translated that onto the lock center line of the door for a cylindrical lock, it wouldn't be correct. What we're trying to account for is that 1/8 of an inch margin between the top of the door and the underside of the header, and this template is based on the understanding that that is indeed the case. But they're not even referring to a door dimension at all. They're literally just referring to where is your frame located inside of the header. It's a strike location, right? So where are you measuring? You're measuring on the frame and on the frame only. Inside of the header to the center line of the strike, let's just say 43 11/16. You add 3/8 to it. That will make you 43 15/16. That's the center line of the lock body in the door. That formula is going to work every time. Well, it will for this lock. So when you chisel out your mortise, when you prep the 86 edge, the government 86 edge, for the cassette into the door, that's your center line. From the center line, you can now find all your different holes. That's what you need. The other crucial factor is, so 43 15/16, right? That's our center line. Go down 1 23/30, I think that's what that says, to the center of the E hole, which is a 1 inch diameter. Go down 9/16. And go over 9/16. I had to look at the other side of the template. It's down 9/16 and over 9/16 off of center line for those holes. And the D hole is a 3/8 hole. That's easy. So you're going to need a 3/8 bit, a 1 inch bit. You've got your center line here. Now the vertical back set, it's 2 3/4. This is a mortise lock. Not all of them are 2 3/4. There are others, 2 inch, 1.5 inch, 2 3/8. 5 inch. There's all kinds of custom capabilities on mortise locks. Not that Schlage makes them, but others do. So be mindful that Backset for this lock is the lock that we're dealing with. Okay, now Backset. Backset requires that we discuss what Backset means. This customer's packing list will be full of drawings. So Backset is the dimension from the edge of the door to the center, the vertical center of the hole. This is 2 3/4. Okay. You can have some different doors, right, in terms of how the edges are prepped. And I'll use the example of aluminum storefront only because it will permit me a bit more liberty to talk about what we're dealing with in terms of how Backset is defined. I'll draw 4 examples here. This is what 4 doors can look like. Square edge, beveled, radiused, and rabbeted. Okay. Backset is defined as the edge of the door to the center of the hole. Backset is also defined as the center of the thickness of the door to the vertical center line of the hole. That's an amazingly important distinction, because in our square edge door, let's say it's 1 3/4 thick, the backset, you could measure from the edge of the door here over 2 3/4. You can measure from the edge of the door here over 2 3/4, and you're good. That's 2 3/4. Well, you try that same routine on a beveled edge door, and that drill bit is going to miss it. You go 2 3/4 from here to here, and 2 3/4 from here to here, you got trouble. Same here. You're going to measure it from here is different than here. Your rabbited door, well, that's easy. I'm sure that that's going to be square, but it doesn't have to be. But if you measured it from here to here, this is a gross example, meaning it's an inflated example, which shows you have to define the backset from a certain point. The point is defined from the center of the thickness of the door. So if our door is 1 3/4 thick, it's actually measured from 7/8 of an inch into the thickness of the door, which really puts it at the rabbet is, I'm not sure what those dimensions are, but you can see that that's what we're referring to. So the 2 3/4 from here is going to be from here is going to be different from here than from here than from here or here, but you're defining it from the center of the thickness of the door. Okay. The important part of all of this is that if you have a beveled edge door and you hook your tape measure on one side of the door and go to 2 3/4, and you do that same logic on the other side, those holes are not going to meet. The bevel, the way that it's defined, the degree, this is actually 93 degree and that's 87 degree. It's also expressed as follows. 1/8 in 2. For every 1/8 of it, for every 2 inch in door thickness, the difference between here and here is 1/8 of an inch. So if I drew that line out, it would look like that. Okay, if it was a 2 inch thick door. So we're going to be just slightly less than that. The point is you've got to cheat that dimension plus basically a 32nd on one side and cheat it minus just light on a 32nd on the other side, so those holes go all the way through. So where you mark the holes, if you've got a square edge door, you're right as rain. You're good. If you've got a beveled edge door, you've got to cheat that depending on where you're marking it from. So what I do when I determine my vertical backset is I will get my template on the door and I literally mark the holes. I step back, I stop, I double check everything, I make sure it's correct. Right, correct side of the door where my holes will be. I don't want to put a cylinder on the inside of a closet door. And then I'll take my center punch. Bam, bam, bam. I'll mark all those holes. At that point, it's easy stuff. If you have the ability to put this into a drill press sort of scenario where you know you're going to drill straight, I'd kind of go through the door. Even though that serves to erupt the opposite face a lot, really drilling from both sides is the proper way to do it. And that just is the proper way to do it. So be mindful that that's what they're looking for. And when those holes are in the right location, which is why I said earlier, before you start to install it, get the lock case in the door and make sure that you've got a nice margin and everything is going to fit perfectly. You don't want to start installing the hardware and forcing it because the lock's going to bind. The levers aren't going to work right. The deadbolt won't throw correctly, etc. So the holes need to be in the right location for that reason, and following the template will get you there. Really nothing else to call out except that all the information is there. I've been staring at templates like this for almost 30 years, and I kid you not, in only 1 or 2 instances did I clearly find a mistake that the factory was incredibly happy that I pointed out to them, because it was just simply wrong. But, you know, the possibility of a template being wrong is incredibly small. And there's really nothing else on the template to call out. I wanted to talk about another reason I don't like this strike is because the hole for the deadbolt and the latch is right in the same location. What you'll find in other manufacturers, not really anyone that Schlage directly competes against, but you'll find that the deadbolt prep is offset. That's because when the door is pushed closed, let's say you have an exterior door, and it's latched. You push it closed against the weather stripping, and then it relaxes ever so slightly. When you go to throw that deadbolt, I bet you that this hole is wider than it needs to be, because that door gets pushed closed and then relaxes that, 60 thousandths of an inch. You throw that deadbolt. Other manufacturers have that deadbolt prep askew or biased towards one side so that you get a really nice tight engagement between both the latch and the bolt into the holes in the frame, because the holes are staggered. The top deadbolt hole is biased to account for account for the fact that the door will get closed and then it will relax ever so slightly. Anyway, that's another reason I don't like these strikes, because they could be better, is the bottom line. Although it would be a nuisance to have handed strikes. Every strike would basically be handed at that point. Nothing else on the template to call out, so I'm going to close that file. There is also a link to the service manual. The service manual is super awesome because it will allow you to review everything that you're going to find as a replacement part for your Schlage mortise locks. And it's very handy as a result of it being there. If you pull that document up, if you like, and just type in 9010, you're going to find several instances where you will locate your 9010 hardware, which is awfully handy because it's going to permit you to get a review or a drawing of what you're dealing with on the 9010 lock. Control F, 9010, and you're going to find all the instances where it shows up. And what's really handy is they will show you the exploded drawing of what everything looks like. That is in the installation instructions, but what they'll also show you further on in the document is a exploded parts diagram of all of the goodies inside of the lock cassette that I didn't take apart. And there's not many parts in there, but there are still at least a dozen parts inside of there. The good part of that is that if you are a hospital, if you're a school, if you're an airport, and you have millions of cycles in just, a couple of years, the ability to be able to pull those part numbers up, get the part number for only what's common in here, part 24 is not unheard of, the hub spring. You cycle that enough, springs are going to break. That's the bottom line. The ability to buy that hub spring only to keep that several $100 lock still working, that's why you buy into a system like Schlage, because they publish that stuff. And that document is irreplaceable as a result of that. You keep going through the document and you'll find other parts that apply to the 9010, the strike, the armor front, other items that may or may not be of use to you. So it's really handy. They even have lubrication specifications, which I would think in those sports centers, airports, hospitals, schools, your maintenance staff, your maintenance director needs to be aware of that, because that's how you keep this stuff running forever. You're doing a public job where you're spending public money on a school, and that school needs to run and last for as long as possible. Yes, there's not money in the budget to buy new locks because they've not been maintained. The point of me lecturing about that is I'm very partial to Schlage, and it's because they put that information out there up front, and they're backed by individuals who are absolutely stellar when it comes to responsiveness and expertise and professionalism. The bottom line thing is this: the technical support people at Schlage know their product, and they know it very well. Now, back to the product brochure. You can scroll through that document as you like. And I will just quickly do so to see if there's anything else to bring to your attention. That document is not it's not your grandfather's Schlage L series catalog. What I mean is there's a lot more in there than there used to be, especially when it comes to the wireless and electrified product lines. Multi-point locks are there as well, which are neat because you'll find multi-point utilized in applications where you need to have latching at more than just one point of the door. Think tornado and hurricane applications where you're going to see multi-point locks used very often, and even at times required, depending on the assembly of the door. But however, the rest of the catalog is nice because you'll not only see, a trip through that product catalog is handy because you'll see not only the roses that are there, but the escutcheons that are there as well, the L escutcheon and the N escutcheon. The variety of different thumb turns are available, not on this, but a privacy or a keyed lock that features the requirement of a thumb turn. Something very interesting that has been becoming more common and popular are occupancy indicators, which are listed there as well. Knowing the condition of the lock door when you approach the door on the exterior side, and sometimes on even on both sides. I've just done a project where it's required on both sides. Schlage can do hospital push-pull latches. They're HL6 from their sister company, Glenn Johnson. In a mortise case, ligature resistant. Options are there. Other technical data regarding the specifications of the entire series. Then you get into the functions, the part number that Schlage uses to identify the operational description of how the lock works. And as you study that, you realize, oh wow, this is really great because the operational description states elegantly and only what is needed to know to fully understand how the lock will behave. So reading all of that's nice. So the L9010, latch bolt retracted by lever or knob from either side at all times. Inside lever always free for immediate egress. So the second line is somewhat of a duplication of the first state. It's except that in this day and age, with really needing to be very clear about how locks operate, they add that language there. They're basically saying if you ordered an L9010, not only is it unlocked at all times and the lever or knob can operate the latch, but you can always get out. Meaning there's no special knowledge. You don't have to unlock something and then rotate and then get out. They're being very clear about that. The ANSI number that's there, in this case F01, or for the L9040, the F22, that's handy because the F01 will, if you search by that function number across every manufacturer that has their products listed or tested by American National Standards Institute, you'll be able to easily convert an L9010 to a Sargent number, to a Yale number, to a Corbin number, etc., etc., etc. So that's why that is there. But really, Schlage's intention is the specification from the architect will call out, I need locks ANSI function F01. You take that F01, you go to your Schlage book, and you say, what's an F01? Oh, it's an L9010. Got it. I don't have the ANSI numbers memorized. Never saw a reason to because I just pull up the catalog. And plus, so as you scroll through that, you're going to get through all of the several and many functions that are very much worthwhile reviewing. And if you have a need for a function that you just can't find, maybe because you're not sure, reach out to us. We'll help assist with that. The last few years have seen the advent of a lot of additional functions, especially as we bear with me one moment. Okay, so especially as our society demands from us additional requirements on how a door will operate, safe school classrooms, things of that nature, how everything is changing, and the manufacturers of locks answer that call. Code officials answer that call. People who think about the direction that hardware is headed in answer that call when they try to help determine different functions of locks that may be more appropriate in many applications. So unfortunately, the days of there being 2 pages of functions are long gone because hardware has answered the call of helping fulfill the needs of society and do so in the safest way possible. So that really gets us through the product brochure. You're welcome to ask any questions that you might have in that regard. Back to the original extended description, we've got some bullet points that are there that talk on the, talk about the overview of some dimensional properties of the item, and that's all buried there. Finally, there is a link below this video to the manufacturer's page where you can pull up not only all of the Schlage products that we sell, but also a link to the manufacturer's website, as well as a link to the full product catalog. Also on that page are several and many encyclopedic documents, service manuals, keying manuals, archival catalogs. I've got a Schlage catalog dated 1982 there. I've got a Schlage catalog that is dated 1972, 1979. I've got a wafer lock service manual there that's from 1959. I have more from mid-century that I'm adding all the time. That page is the repository of all of our archival documents. So it is the consolidated page to find everything that we have when it comes to Schlage, a company that I am, again, very partial to, and it is because of that excellent technical support, and plus it's a very high-quality product, but they're backed by excellent technical support, no doubt. Walter R. Schlage is, in fact, the person who started the Schlage Lock Company. 1920s, don't quote me, I forget. But he has many patents. His important patent was basically the cylindrical lock, the Schlage A-series lock. He invented the way by which the mechanism to affect movement on the latch bolt is contained within the housing. So he is credited for the invention of that format of lock, what became the cylindrical lock. Very interesting. If you just go to Google Patents and type in Walter R. Schlage, you'll find lots of stuff. Any questions on the L9010 and an 03B and a 626 finish or any other Schlage product, please feel free to reach out to us. And thank you.